Is math required for civil engineers? What do you think? The answer is yes. Check out the latest FE exam question that will make you understand why. Question number 30. The shear diagram for a specific beam is presented below. All the lines in the diagram are linear. No bending moments or concentrated couples present along the beam. What is the closest value for maximum bending moment in kilonewtons into meter? That is a unit within the beam. So if you look at this unit, kilonewtons into meter, that's a combination of multiplication between kilonewtons on the x-axis and meters on the y-axis. So the area of these diagrams is what gives you this kind of unit. Okay. So in this particular shear force diagram, there is 4 different areas. When they say maximum bending moment, if you find the area of each of these different polygons, the polygon with the maximum area is what gives you the maximum bending moment. Okay, that is very simple concept. And in this first polygon, you can see that we have dimensions of x and y. Okay, there is 2 different y's, y1 and y2, but you can average it to 14 meters. I mean, negative 14 kilonewtons. Same on this side, for this fourth area, you have 4 on the y-axis, 4 on the x-axis. So you know that you can easily find that area as well. But when it comes to these 2 triangles, which are similar because they have 2 adjacent sides and 2 hypotenuses that collide with each other. So for these triangles, the outer part of this triangle is 6 and outer part of this is 4, but the inner side, it's not given. We know that if you mix this A1 plus A2, it comes down to 12 meters. That much we know, but we don't know what exactly is A1 and what exactly is A2. That we don't know. So if we find this A1 and A2, we'll be able to find these 2 areas. Then whichever of these 4 areas is the highest magnitude, that gives you the maximum bending moment. You understand? That is the concept of this problem. So with no further ado, let's get into solving it. So here is the given. In this diagram, this red part, that is what we don't know. That's why I highlighted that. 12 meters is the span of A1 plus A2. Okay. The outer part of this triangles, I'm calling it as O1 and O2. So O1 is 6 kilonewtons, O2 is 4 kilonewtons. We are required to find the maximum bending moment. We already discussed. So here is a detailed diagram showing you the same. Area 1 is nothing but the multiplication of 14 times 2, because you can simply convert this trapezoid into a rectangle by averaging this y1 and y2 to 14. Area A4 is multiplication between 4 and 4, that is 16 kilonewton meter. Area 2, area 3 we don't know. So for calculating A1 and A2, we are going to use the principle of similar triangles, which is the sum of outer sides by sum of adjacent sides is equal to any individual outer side by any individual adjacent side of a specific triangle. Okay, O1 plus O2 by A1 plus A2 is equal to O1 by A1. That is the formula we will use for solving this. So O1, as you can see from here, is 6 kilonewtons. A1 is what we don't know, the unknown. 6 kilonewtons plus 4 kilonewtons by 12 meters. That gives us A1 is equal to 4.8 meters. Since A1 plus A2 is equal to 12, you will find that A2 is equal to 7.2 meters. This is what we use to find the area of both the triangles. Okay, area 2 and area 3. Once you find the area of both the triangles, we will be comparing area of all the 4 different areas. Area of number 1 is 28 kilonewton meter. We found that way in the beginning. 28 kilonewton. Area of fourth area is 16 kilonewton meter. Area of both the triangles is 14.4 in this case, which always doesn't happen. So once you compare all of them, the first area is the maximum bending, and that is how we solve this problem. So the correct option is option D.